Hi, in this presentation, I'm going to introduce the development of an intelligent conversation application. It's called Fitness Advisor. First of all, let me introduce some background. In Australia, gym workout is the most popular exercise as there are 7.8 million of people doing it. Among them, 4 million people, which is more than half of them, like to use fitness app to help with their exercises. And from this figure below, we can see using fitness apps is very common from young people to elders. So we can see the market for development of fitness application is in high demand. We also have some problems in terms of doing exercises. First of all, we all know exercise are good. We can lose weight or gain muscle and live in a healthy lifestyle by doing it. On the other hand, to ensure effectiveness, we need to associate it with proper nutrition intakes, like just eating healthy. However, according to study done, doing wrong exercise is harmful. It is both only prevent from body recovery, but also cause injuries and other serious health issues. Also, despite many people using an app to help, they can't ensure whether using is really helpful. For example, using a tracking app to track your behaviors does not necessarily make you cultivate training habits. So it is very important to develop a fitness app that can really help and ideally keep people away from those health issues like injuries. And this is what we are going to have, and it's also what we're expecting to have in the application. So it's going to generate training information like training plans and meal preparation based on users' data and needs, such as their weight, body weight, height, body fat, and training preferences, etc. Users are going to speak to the chatbot to input those user data, and then the system will gather information online using crawling and segmentation. Then what you will see is a list of training information and recommended places to get ingredients for healthy food, for some healthy food, so you can use it for meal preparation. And next, I would like to introduce some related works based on 5 academic papers. The first two are about usability of 2 well-designed fitness apps. From these, we can benchmark the goal we're going to achieve and limitations we're going to overcome. So the first app is called MyFitnessPal. In the app, users can input their fitness goals such as weight, body fat, calorie consumption, etc. Then the app would tell you how much calories each day you need to take. So basically, it's going to help you to track what you're going to eat every day to ensure what you're eating is within a safe amount of calories intake. And by scanning the food, the app will display how much calories it contains. And this is the interface of the app, as you can see. And in the middle is the breakfast the user is going to have, and he probably scanned the product they're going to consume. So the amount of calorie for each of them is displaying here. So these are summed up to align with the goal you're going to achieve. And this amount of calories remaining that you're going to take. which means you can't eat more than this amount of calories in this day. So, and in an experiment of 1.4 million samples, nearly 20% of users achieved their goal, taking 100 to 300 days. And it's reasonable that the harder the goal is, the harder it is going to be achieved. And this can be seen in figure 2. The first goal is the hardest one, and it is hardest to be achieved. And the last one we can see is the primary motivation affecting the goal achievement. Obviously, a goal is more likely to be achieved if the user's motivation was being healthy. So it's very important to keep them away from health issues in using an app, which is a good way to maintain your customer base. The next example is an application called Goalpost. It has 4 main features. The first one is goal setting. So in terms of just one goal is being set, the user can set another one, which is an alternative goal, which is easier and faster to be achieved. And the second one is reward. The user will get rewarded once their goal is achieved. And the third one is self-monitoring. The user can receive reminders of how many days they haven't been working out. And the last one is by sharing. The user can share their goals and what they have been training today to the society and share to other users who are using this app, so they can be getting some useful advice or suggestions from others. So as same as the last one, they were doing an experiment to find the effectiveness of these features. And we're going to see some outcome in the next page. And here are 4 outcomes by using this application. The first one is the primary goals. So the user can set 2 goals. One is the main goal, and another is the easier one. So they turned out very good because the user can go for the easier one rather than the hard one. And the next one is about the reminders. So rather than having a reminder of how many days the users haven't been working out, they rather to have a reminder of what's today's working out plan. And they can scale the way to remind based on the user's preferences. And the next one is the representation of the rewards. The representation of the reward they used is a cartoon trophy, which is too childish. It's better to use another way to represent it. And the last one is the support from sharing. They should share some particular categories of what they're doing each day, like did they jog, did they heavy lifting, did they train their leg, so they can share this to related users and get some valuable information or advices. In the following related works, I'm going to introduce some technical details. They're about the technical details I'm going to implement in my application. So the first one is recurrent neural network. They use the recurrent neural network to classify web pages into different categories. And let's take a look at the entire process. So they input a web page, say the web page has this text, and this movie is very good, and the text is going to being converted into number, and the number then converted into vector by word embedding, and the vectors are as input going to the recurrent neural network and the dense layers, and finally the output is the category that this text belongs to. And it also has some limitation, which is the success rate lower than expected. It's just 80%, and it's expected much higher than that. And one of the way to improve it is hyperparameter optimizations. And this related work is kind of similar to the last one. The last one is using a recurrent neural network. This one is also used the recurrent neural network, but with LSTM, which is long short-term memory. It is used for preserving the long-term and short-term hidden layer, the hidden states in the layer's information. So the information won't lost during training. And because there's a conversation, as you can see the data set, the chit-chat data set, so it's from daily conversation. It firstly go into the pre-processing and they become vectors and they are input into the current neural network with LSTM cells. So after training, the system will understand the meaning of the sentence. And the goal is to pair the question and responses. So they eventually will build a chatbot that can answer the question that people ask. And the last work I'm going to introduce is about crawling and segmentation. So crawling is to get information from web pages, and segmentation is about segment the web pages content based on the DMO tree. So in this paper, they were using an advanced technique for segmentation. It divided into 3 phases. The first one is analysis. The second one is understanding. The third one is reconstruction. And each phase is using a different algorithm to achieve. So from this diagram, we can see a web page is going to be input, and through the first step, which is rendering, they extract the DMO tree. And based on the DMO tree, they use an algorithm called D2C to analyze the DMO tree. And then they mapped the structure into a logical structure for understanding using this C2L algorithm. And the last step is to reconstruct the web page. And you can see the function is below here. And you can see the D2C is the algorithm we just said, and the C2L is the algorithm for understanding we just introduced. And they put them together. The web page is constructed. And I'm going to introduce some methods I'm going to implement. The first one is web APIs, and first API I'm going to use is geolocation API. So we're going to recommend some stores for users to buy their ingredients for meal preparation. And it's important to access the geolocation to show the store nearby. And after they get some store recommendations, they would like to know the navigation to get to the store. So it's useful to use a place API to show the location on the map. And the last one is the web speech API, which is the most important one. It's used to convert the user speech into plain text. So the text will be used for further processing, such as crawling, and so they can gather information based on the text, like searching. And then I'm going to use the dataset to train the model, so the system can understand the web page gathered online and then classify into categories that meet the user needs. And the dataset I'm going to use is called Kaggle Web Classification Database. It contains this number of English web pages and also contain a test set, but there are more than 400 of them are not categorized. And also there's an edge list to show the connections between each nodes. It's like a graph. There are 3 NLP techniques I'm going to use. So the first one is called tokenization. Tokenization is to encode sentences into the numeric values. Like the first one is I love my dog. It contains 4 words and each word is converted into a number. And the next one is padding. So padding is like the last figure. And so each sentence might have different length. And like this sentence has 4 words, and this sentence is longer than 4 words. So we're going to use some special token to represent the missing words to make sure they're having the same length for further processing. And the last one is embedding. It's going to determine the sentence's meanings. And in this example, you can see if we determine 2 main attitudes, which good or bad. If we say no bad, then no bad is converted into a vector pointing in this direction, means between good or neutral. So there are 2 techniques I'm going to use. One is data classification, and it's going to classify and get information from the web pages. And the second one is long shortened memory. It's advanced techniques for better constructing a recurrent neural network. And next, I'm going to introduce the entire system architecture. So firstly, the user will speak some words, speak sentences, and then their voice will be converted into text, and the text is used for crawling and segmentation to get information from online. And meanwhile, the user's geolocation will be accessed for recommending the stores for them to buy the ingredients for their meal preparation. And the web page gathered online will go through data preprocessing and then go into the LSTM model, which is a recurrent neural network, and then the categories of the web page coming out from the model. So we can list this information based on these categories for users' better readability. And if they just enter one of the entries containing the store recommendation where they can buy the food, the map will show to tell them how to navigate to the location, how to go to the store on the map. And in conclusion, our application will be a chatbot application, and it's going to provide some information about exercise plan and meal preparation. Also recommend some stores to buy those ingredients for your meal preparation. We also introduce some related works, show how important usability is to maintain your customer base. And then there's some advanced techniques such as recurrent neural network, long short-term memory, and this advanced segmentation techniques were used in the previous works. We can also learn the advantages from that to improve our application. And the last one is the web APIs and the AI techniques I just introduced that will be implemented in my application. And these are the sources of the paper I reviewed for introducing the related works. And thank you very much for listening.